Hi. So we will make the understanding of periodic trend simpler through this video. Now, to begin with, we will first discuss about atomic radius, and then we will slowly go for electronegativity. So first, let us begin with the atomic radius uh, trend in the periodic table. Now, we know that in this periodic table, we have two things. One is this is called your period, okay? And this is called your groups. Now, what's the difference here is this one tells you that it has +1 valency. You see, the 2 tells you it has +2 valency. So it's like that. Whereas these numbers that you see for down the group, actually, so that number is little different. Now, this number 2 tells there are, two shells, two shells. The number 5 means there are 5 shells. Yeah. So it is like that. Now, when you go across the period, okay, the number of shell remains same. Number of shell remains same. That's a very important point here. Remains same. Whereas when you come down the group, number of shells increase. Number of shells increase. Okay. So that's a main difference between group and period. And then we will slowly understand more detail about what happens to atomic radius here. So now coming to atomic radius to discuss this, it shows that, this side, the atomic radius is less, and this side, the atomic radius is more. So we can compare two elements, maybe lithium and oxygen. Let us compare and understand why oxygen is having less atomic radius. So oxygen has a less atomic radius, whereas your lithium has more atomic radius. Okay. So I have kept here both the structures here. Now, first we will discuss across the period, and then we will discuss down the group. So across the period, what happens is, as I have written out, so if I take lithium, it has two shells. It has two shells, if you see, right? It has K, which has 2. It has L, which has 1. If I take oxygen down here, then this also has 2 only, because K has 2 and L has 6. So technically the number of shell is same in both the case. Then what is the difference now between this? So that we have to discuss. Now, if you look at oxygen, technically it has 8 proton and 8 electron. If you look at lithium, it has 3 proton and 3 electron. Now, what does it mean? It means that the charge in oxygen atom is more. So what do we mean by charge is more? It means that the proton and electron is more, and because there are more proton and electron, the force of attraction is also more. The force of attraction is also more between them. Yeah, is also more. Now coming to the other side, where we have technically a lithium. Lithium has less electron and proton, right? Less electron and proton. So what does it mean? It simply means that force of attraction is less. Force of attraction is less. Now, this means even though you see both have 2 shell only, so both have same shell. So technically because the force of attraction is more in case of oxygen, the shells get closer to nucleus. So the radius decreases. Yeah, radius decreases. Now, whereas if you look at the lithium, it's other way around. Because the force of attraction is less, the shells don't don't get closer to nucleus. And that is why its size remains big, which means the radius remains bigger. Yeah, radius remains bigger. So the whole funda is about how much attraction, so all these electrons are getting attracted to the nucleus because there are 8 proton also here. Yeah. So all these electrons, they're getting attracted to the protons. So if there are more electrons, then the attraction is more, which also means that due to this more attraction, these shells will move closer to nucleus and then their radius will decrease. Okay, that's a whole difference between your oxygen and lithium. Now, because oxygen has, radius lesser than lithium, that is why we show that the atomic radius increases this side. You can also write that atomic radius decreases this side towards oxygen, which is also fine, no problem. Okay. Now that is across. Okay, that is across we spoke. Now we will talk about down the group. In the same group, what happens? Now let us take 2 more examples. I will take lithium and potassium here. So down the group we are going to now analyze. Okay. So down the group, if you look here, lithium has 2 shells. Yeah, we have seen up also. K is 2, L is 1, and your potassium has now more shells. You see. So the number of shell now increases down the group. So potassium has 3 shells, because your K will be 2, your L will be 8, and your M will be 1. So now 3 shell means, you see, they are spread more far away. Yeah, technically. So potassium has more shells compared to lithium. Yeah. Hence, its radius is more. So that is the reason why its radius is more. So I hope you understood the difference. Okay. So technically, you should know that when you discuss across the period, this side, across the period, then your number of shells are same. So 1 means everybody has 1, 1, 1. 2 means lithium has 2, oxygen has 2. But oxygen has more electron, proton, so attraction is more. And that is the reason why, due to attraction, oxygen will shrink little and the radius will decrease. Whereas lithium, there won't be much impact because there are very less electron and proton compared to oxygen. Now, that is about atomic radius. Now, let us go for the next one. The next one is about electronegativity. So, let us see what electronegativity means to us. I will take again examples and do so that it is much easier for us. Okay. So, we go down a little bit here. And now comes electronegativity. Now you can see the electronegativity trend. So electronegativity increases. Yeah. So this is across the period. Okay. This one. All right. And this one is, I'll take another color so that we understand easily. And your second, this one is your down the group. Down the group. Down the group. So down the group will be this one. So let us discuss one by one. Now, keep in mind that across the period, the electronegativity increases, right from lithium to, fluorine. So we are going to again use lithium and oxygen to understand this example. Now we come here. Yeah. So this time we are going to understand electronegativity from the point who needs more electrons or who need less electron. So technically, electronegativity means ability of atoms to attract electrons, to attract electrons. Okay. So who will attract more electron? Who will attract less electron? That we have to see. Now, coming to lithium, if you look at the lithium here, so lithium, as we have seen, your valency of lithium, valence electron, let us write first. Valence electron for lithium is 1. Okay, the last shell, this one. This is the valence electron. Okay. Now, lithium needs, it can donate 1 electron. Yeah. It can donate 1 electron. So, donate 1 electron. And why does it donate 1 electron? To attain stability, Yeah. The rule of stability is either your last shell is full or last shell has 8 electrons. That's the rule. Okay. So in this case, if you remove the last one, this electron, if you remove it, yeah, if it donates this, then his K shell, which can occupy 2, is already full. So it will become stable. Okay. So we write lithium as lithium plus 1. Remember this. Okay. We are going to discuss with this. That's how you write. So that plus 1 is your valency. That plus 1 is your valency, which means how much it can give, how much it can take. So if it donates, it is positive. Just remember that part. If it donates, it is positive. Okay. Right. Because it is losing electrons. So it will be positive. Now come to oxygen. Let us understand oxygen also now. So in oxygen, what happens now? In oxygen, if we look at oxygen, it is technically having valence electron in the last shell. If you count valence electron, there are 6 electrons. Yeah. There are 6 electrons. You see these electrons, 1, 2, 3, 4, 5, 6. So valence electron is 6, which means it needs 2 more electron to make it 8, you see, and attain stability due to which rule? Due to octet rule. So how do I write oxygen then? I have to write oxygen. I have to write oxygen as -2. There's some problem with my pen. So -2. That's a way you write oxygen. So keep this also in mind. Now we will discuss both. So technically, if I have to discuss both here, so if I write lithium, which is +1, and I write oxygen, which is -2, what is our understanding? Understanding is that it will donate and this will accept. What? Accept electron. You see? So in this case, oxygen, because it is ready to accept, now it is ready to accept. So it is easy to add electron. Okay. So moreover, it needs electron. So it's very easy to add the electron. Yeah. This also means that we need less energy to add. We need less energy to add. Now come to lithium. What happens? Let us see. In lithium, what happens is lithium is +1. So it will donate. It is not going to accept. So it will donate. When it donates, which means it is difficult to add electron, which means we need more energy to force electron inside atom. Yeah. We have to literally do a lot of work to push the electron inside atom in case of lithium. And that is why we say that the tendency to accept electron to accept electron is more in oxygen. Yeah. And because the tendency is more, so we say oxygen is more electronegative. Electronegative. Now you see, you understood this part now. And that's the reason why your these atoms, which are actually in the other end, they always like to accept electrons. Okay. So they accept electrons. So all these people, they accept electrons very easily, accept electrons. Whereas all these side people, they like to donate electrons. Donate electron, which means you can't push electron easily inside these elements. Now that is, we are talking is across. Okay. We are comparing across the period only. Okay. Now, let us see what happens down the group now for the electronegativity, because that's also a very important aspect here. So let's go down. Across we have seen. Now we go down the group. So let us see what happens down the group. I've taken again lithium. Lithium will be our common example so that it's very easy to understand. Now looking at down the group, what we have to understand here. Okay. So technically, if you look at the electronegativity arrow, it shows that lithium should have more electronegativity than your potassium. We are taking lithium and potassium as our examples. Okay. So lithium should have more electronegativity than potassium. Let us understand why lithium should have more electronegativity compared to potassium. Okay, fine. Now, lithium, once again. Now, lithium has a very less distance. Okay. So if you look at this D1, let us put, and let us say the distance of potassium we do, D2, then we very well know that the distance of the distance of potassium from center is more than lithium. We all can understand that because easily we can see that. Lithium. Now, if the distance is more, what does it mean? So let us put again lithium and potassium this time. So lithium, now we are comparing between lithium and potassium in group. Okay. So we know that we have seen just now up in the atomic radius also. Yeah. So lithium technically is smaller. Potassium is bigger. That means smaller means your radius is less. Yeah. And less radius also means electrons closer to nucleus. And in nucleus, we have proton and neutron. So protons will attract more. So proton attract more. Yeah. Right. Now, if proton is attracting more, then whether it is easy or whether it is hard, we will discuss after some time. So let us write about potassium also now. So in potassium, what happens? Potassium is bigger, which means radius is greater. Yeah. Radius is greater, which also means that electrons are far from nucleus. Which electrons? Not every electron, but especially the valence electron are far. Okay. They are far from nucleus. All right. Now, because it is far, and in case of lithium, it is very closer. So we can say that due to lack of attraction, attraction of valence electron, it is harder to add to add more electron, yeah, to potassium. Now, if we look at the lithium one, then lithium has another way of approach because proton attract more, which means more what? It will attract more the electrons. Which electrons? Electrons in valence shell. Valence shell. And due to this attraction, due to this greater attraction, we can add electron easily. But easily in the sense compared to potassium, okay? Not across. It is just down the group. Remember that, okay? They are all in same group actually, right? So question is that lithium, now let us go back, you see there, again that chart if you see here. So if you look at this table here, so technically we now understood that lithium can accept electron faster than potassium, yeah. So that is why, so lithium has greater electronegativity. Okay, so I hope this is now clear. So there's a difference in the way you analyze them, okay? So you should not get confused that, across the period, lithium has the least electronegativity compared to oxygen. Whereas when it comes down the group, lithium has the higher electronegativity compared to even your potassium. Okay, so the whole idea is about they have a different approach there, both of them. So I think we will stop in this, and the next video I will add and discuss about reactivity. Okay, so we will stop here.